Hey everyone, we are going to be looking at lesson 10-7 beginning on page 705, and I'm going to be moving through this as quickly as possible to partly to free you up for homework time. So let's start by looking at the information just above example 1. Again, lesson 10-7, page 705. Now, we are going to be starting with the volume of a pyramid, and then we'll be moving on to the volume of a cone. And you will find these two formulas to be super similar. All right, looking at this, here's the picture of the pyramid. There's an oblique pyramid, and you can tell that the height has to go from the vertex or the apex down to the plane that holds the base perpendicularly. And in this one, that's easy. It just runs right down the middle of the pyramid because it's a right pyramid. Okay, our formula is volume equals 1/3 the base times the height. So if you get rid of the 1/3 and you just look at the rest of it, it's not really the base, it's the area of the base, which is why it is capital B. And so that is just like our volume formulas that we learned previously. But this doesn't use up all that the prisms and the cylinders used up. In other words, this pyramid doesn't extend straight up in all of this direction, and that's why we take 1/3 of it. It's only 1/3 of that total amount that is needed to fill up the pyramid. So 1/3 the area of the base times the height. So of course we'll start by finding the area of the base depending on what shape the base is, multiplying it by the height, and then dividing it by 3. Let's look at example 1. Example 1 says find the volume. I'm not sure how my phone's going to work with this. Hold on. Find the volume of each pyramid. The first one is a rectangular pyramid with a length of 7 feet, a width of 9 feet, and a height of 12 feet. And that is not drawn. So let's come over here. This is a rectangular pyramid. We'll just keep the drawing super simple, but it would look something like this and this. Okay, and it would be 7 feet, 9 feet, and the height right here, and we can do that way, is 12 feet. Okay, now our formula says volume equals 1/3 the area of the base times the height. One thing that I may not have thought to tell you previously, actually I think I did, always start these equations with the formulas so that you're learning the formulas as you go. So we've got 1/3 the area of the base. How do we find the area of a rectangle? Simply 7 times 9, which is 63, multiplied by the height, which is 12. And when we say 63 times 12 divided by 3, our answer is going to be 252 feet. And remember, this is volume, so it's cubic feet. All right, let's move on to the next one. The next one is this picture right here. It says it's a square pyramid, and we want to find the volume. So here's our formula. 1/3 the area of the base times the height, which is 1/3 the area of the base. Here's the area of our base. 4 times 4 because it's a square. So 4 squared times the height, which is 6. We do the math on those. We say 4 squared, which is 16, times 6, divided by 3 equals 32 inches cubed. Pretty cut and dry since you're used to finding volume already. All right, let's look at the last example of this. And it is a trapezoidal pyramid with base ABCD, here you go, where AB, the top of the trapezoid, is parallel to CD. So the two bases we know are AB and DC because they're parallel. And where AE, where's AE? There we go. AE is perpendicular to plane ABC. All that's helping you realize is that that is actually the height of the pyramid. That's why they tell us that it's perpendicular to this base. That's how we know that we can use it as the height, is because it is perpendicular. All right, here I have done the work right above it, and we're going to look at it there because that way you can see the diagram and the work at the same time. So of course it's 1/3 the area of the base times the height. So we're going to say 1/3 times that area of the base times the height. Now let's look at how we find the area of the base of a trapezoid. Do you know how to do this? We have to find the average base, so we're going to say 9 plus 18 divided by 2, that's what you see right there, times the height. So the average base, here's the average base, times the height of 16, and then, of 6. And then we're going to multiply it by the height of the overall pyramid. So here we have 1/3 times the area of the base times the height of the pyramid, which is simply 81 times 10 divided by 3, and we get 270 meters squared. All right, this one is another tricky multi-step problem, so let's run through this as quickly as possible. A rainforest pyramid in Galveston, Texas, there you go, there's your rainforest pyramid, is a square pyramid with a base area of about 1 acre and a height of 10 stories. Estimate the volume in cubic yards and then change it into cubic feet. 1 acre equals 4840 yards squared, and a story equals about 10 feet. So let's look at this in my notebook, even though it's done for you in the book. The first thing they tell us is that the base area of this is about 1 acre. Let's start with our formula. Volume equals 1/3 the base area, or the area of the base, times the height. Okay, now let's look at our base area over here. They told us that it's that the base area is about 1 acre. They also told us that 1 acre is equal to 4840 yards squared. Now, how are we going to find out what each side of this is? We're going to take 4840 yards squared and find the square root of it to find what each side was. So it's kind of like if we had a square and they told us that its area was 9 feet squared, we would need to find the square root of 9 to find that the sides were 3 and 3. That's the same thing we're going to do here, and we find out that each side is approximately 70 yards, okay? So we can do, let's see, our 70 yards. And our height is, it says, about 10 stories, and 1 story equals 10 feet. So 10 stories times 10 feet each is about 100 feet. Okay, this is going to be our height. This is our length and width right here. All right, so now we've got some work to do. Let's come back over here, and we're going to be dealing with yards first. So we're going to say our volume is 1/3 the area of the base. The area of the base is going to be 70 squared, or that number right there that we already used. So 70 squared times the height. Now our height is in feet. So let's change our feet to yards. So we have 100 feet over 1 times, here's our conversion relationship. We want to go from feet to yards, so we've got to get rid of feet. We'll put yards on the top. We know that 3 feet are in a yard, and we know that feet cancel, and we know that 100 divided by 3 is about 3.33, something like that. So we're just going to say approximately 33 feet. I'm sorry, yards. We changed to yards, forgive me. Now let's come over here and put that into the height, 33 yards. When we multiply all of this together, we find out that the volume is 53,900 yards. Now remember, this is volume, so it's cube. Yards cubed, or cubic yards. All right, so we have the first part of our answer. We have the volume in yards, but now we want the volume in feet. So we're going to say 53,900 yards, cubic yards, over 1 times our conversion relationships. Now, here's how they did it. Right here, they said 1 yard cubed equals 27 feet cubed. I'm going to show you the long way to do that so that you really understand what's happening there. We have to have yards cubed, so we need yards times yards times yards. That means we have to have that relationship 3 times. I know you can't see all that, but you can now. Yards times yards times yards over feet times feet times feet. And we're going to do our conversion relationship 3 times. 3 feet are in a yard. 3 feet are in a yard. I just did all this backwards. I am so sorry, forgive me. Let's talk about why I did it backwards or how I did it backwards. I needed to get rid of yards, not change to yards. So yards have to be where? On the bottom. Remember that? Sorry, I'm making such a mess of this. So now we have yards on the bottom and we need feet on the top because we're changing to feet. So I'm going to try to be a more reasonable teacher and rewrite this. Yards cubed over 1 times feet over yard times feet over yard. I'm trying to hurry, so I know it's kind of messy. Times feet over yard. Okay, I'm sorry I did that backwards the first time. Now what you can see here is that yard times yard times yard, or yard cubed, is going to cancel with yards cubed. So we'll come back to that in a second, but there are 3 feet in every 1 yard, so there's our conversion relationship. And now we can cancel yards cubed with yards times yards times yards. And we say 53,900 times 3 feet times 3 feet times 3 feet equals a whole lot. It equals 1,455,300 feet times feet times feet, or feet cubed. And that's all we had to do for that problem. We needed to do it in 1 unit first, which was the yards, and then change it to, or the yards cubed, and then we needed to change it to the feet cubed. Okay, let's go to page 707. I'm going to stop this video and start a new one on cones.